Hello, everyone. Welcome to another hangout with your favorite interview buddy. This is the third lesson in the Data Structures and Algorithms Simplified series. In the last lesson, we talked about arrays and lists and implemented them using Python. In this lesson, we will practice using an array to solve a LeetCode problem. Today's problem is called twosome and it is tagged easy on LeetCode. This lesson will be in two parts. First, we will talk about the algorithm for solving the problem and come up with a small pseudocode. Then, we will implement the algorithm using Python. The problem statement states that given an array of integers numbers and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. For example, we get the input array 2, 7, 11, 15 and a target of 9. The expected output is 0 and 1 because the elements at indices 0 and 1 add up to 9. Let's bring out the parameters in the question. It typically means that we need a method that takes in an input array and an integer target, and it should give an output, an array output that contains the indices of numbers that add up to the target in the array. For each element in the array, let's calculate the difference to the target. That means for 2, we need to look for a 7. For 7, we need to look for a 2. For 11, we need to look for -2, and so on and so forth. That means for each element, the difference between that element and the array must be present in the array for both of them to be the result. That means that for each element, we need to search through this array to look for the difference between that element and the target. A quick approach that comes to mind would be the brute force approach. Loop through the array the first time, and then for each element in the array, search the array to find the difference between that element and the target. And then if you find it, you return your answer. Why is this brute force approach not really good enough? It has a nested loop, and nested loops are of quadratic complexity, and quadratic complexity is not good enough. We'll talk more about complexities in a future video. Now, can we do better? Can we improve our algorithm? How can we do better? What makes our current algorithm quadratic? It is because of the inner loop, the second loop, while we are trying to search for the difference between the element and the target. Can we get rid of this loop? How can we do that? We can do that by trying to analyze what does this inner loop do, and can we do this in a smarter way? The inner loop just searches and looks for the difference between the current element and the target in the array. It tries to check, is there any other element in this array that is equal to the difference between this current element and the target? Can we be smart about this? Do we have to look through the whole array every time we are trying to search for a new number? How about we create a store of all the values and indices that we have seen in the array as we loop through it the first time? And then when we are trying to search for an element, we easily just check our store for that element instead of looping through the array each time. At the end of our loop, our store can look something like this: value 2, index 0, value 7, index 1, value 11, index 2, value 15, index 3. And in most cases, if we find our answer before we get to the end of the array, we wouldn't even need to build the complete store, because if we find the answer earlier, we don't need to do this. Now let us rewrite our pseudocode. The optimal solution would be that we loop through the array. We create a store first, then we loop through the array, and then for each element in the array, we just check our store to see if we can find the difference between that element and the target. If we cannot find it, then we just update our store with that element and its index. Let's walk through the example. So when we start our algorithm, we have our input and then we have an empty store. While we are looping at index 0, the value is 2. What is the difference between 2 and the target? It is 7. Then we check our store. Does our store contain 7? Have we seen 7 before in this array? Currently, our store is empty, so we've not seen it means we've not seen 7 before. So what do? We store 2 in our store and the index. So at this point, 2 is in our store with index 0. Now we continue our loop. Now we're at index 1. The value at index 1 is 7. What is the difference between 7 and the target? It is 2. Now we check our store. Have we seen 2 before while looping through this array? Yes, there is a value 2 in our store. It means we found our answer. So we get the index from our store and the current index that we are, and then we return that as our answer. Now let's implement this in Python. Now let's implement our brute force algorithm in Python. The algorithm states that we should loop through the array the first time, and then for each element in the array, we should have a second loop that searches through for the other pair. Let's implement this. For I in range length nums, this is our first loop. Then our second loop for j in range I plus 1 and nums. If the element at index I and the element at index j add up to the target, then we found our answer. So return index I and j. This is how to implement the brute force algorithm. Now let's implement the optimal algorithm. For the optimal algorithm, we would be introducing a new data structure that we haven't talked about, which is the hash map. In Python, it's simply called the dict. We'll be using this data structure because it allows for constant lookup time, and this is what we need to optimize our solution. So instead of searching through the array a second time, we store all the values and the indices we've seen in this dict, and then we can look them up in constant time. We will talk more about dicts in future videos. Now, the optimal solution says we should loop through the array, and then for each element in the array, we should check the store to look for the pair in constant time. Let us implement. So our store, as mentioned earlier, would be a dict because it allows for constant lookup time. Then for I in range length nums, what are we looking for in our value store? It's literally the difference between the current element and the target. Target minus nums I. Now, if this difference is in our value store, it means we have found our answer. If difference in value store, say return value store difference, which is the index that we stored in the value store for this difference, and the current index. Question says we should return them in an array. Else, what do? We need to update our value store. Value store nums I is equal to I. So this is the implementation of the optimal solution. You don't have to understand everything in this solution yet because we introduced a new data structure. But this is how to use a dictionary that allows constant lookup time to optimize our quadratic solution in the initial approach. Now let's test our, looks like we have an indentation error here. So now let's test our solution. See here that we get the same result for both the brute force approach and the optimal approach. But the optimal approach is the best approach to use. Thank you. Now we have come to the end of today's lesson. Try to practice what you have learned today by solving more array-related questions on LeetCode. You can also rewatch this lesson as many times as you want till you are able to answer all questions confidently. Thank you for watching. See you in the next lesson where we will solve more LeetCode problems using arrays. Please like this video if you found it useful. Hit the subscribe button and turn on notification so you don't miss out on upcoming tutorials. Thanks again for watching and see you in the next video.